Hello. In this video demonstration, I'm going to cover the multimedia collaboration tools, conferencing, telephony, two-party calls, application logic regarding that, and so on. The topics are spread in many parts. So how to use the shared storage is here, two-party call, multi-party call logic here, and most of it is in these two topics. This will be a long demo video compared to others. So let's jump right into it to the shared storage component. I provide a component for implementing a real-time database API, which is used by all these different use cases and other components for multimedia collaboration tools and so on. Now, the shared storage is an abstract tool component, and then actual implementation will be based on something like REST server storage or Firebase storage or even peer-to-peer storage, which are included. All these three are included as part of the project. If you just use shared storage, it uses local storage, but if you use REST server storage, it will use an external storage and so on. These were described in one of the previous demos, so I won't go into details, but the basic idea here is that once you have this component, storage component, it provides you with object and list abstractions, which you can store information. You can use simple create, update, read, delete APIs on those. But more importantly, you can also receive notification when something changes in those objects or list of objects by some other endpoint in the shared storage. And that concept essentially is used by a variety of applications to implement things like text messages, presence, notifications, and so on. So let me go to the next topic here. This is how to do one-to-many broadcast using that storage APIs. It shows all these examples, what kind of resources you can use in the shared data. And this particular demo is basically using a radio station or TV station kind of model, where there is one station which is published with the name first, so I can subscribe to it. This user is received from first. This one wants to subscribe to second or something else, so when second comes up, it can subscribe to second, and when first goes away, they go away. So this is just showing one-to-many broadcast using that shared storage model. This one shows how do you avoid duplicate publication to the same station name as an example. So one is already published, second one cannot publish it. What kind of construct you need behind the scenes to ensure that the object doesn't exist when you try to create it. Two-party call, simple use case where one person registers with a name, say Alice, another person registers with the name Bob. Alice wants to call Bob. It looks up where the Bob is, user client is, sends a message to that resource, that shared object, and Bob receives that notification, responds saying that I'm available to receive the call, and call continues. Now once the initial signaling is completed, they can exchange things like what is my stream name, what is your stream name, and they can connect and listen to each other's stream name. So here, first one is in the idle state, is sent an outbound invite. This is showing early media. So when the invited state, this is the media of the other guy. This is the first user agent, second user agent. If I answer it, it gets connected, both the videos get displayed. And the application logic is shown in the example code here that you can view. Then it also shows how to do multiple lines. So in this case, two users can be registered in two different phones. So Alice has registered at two places, Bob has registered has two places. When Alice sends an invite to Bob, both the phones ring. Bob answers from one of the phones. These two get connected. This phone clears up. Now this guy can unregister, register with another one, say Carol, and then Bob can try to invite Carol and see if it works, or Carol can try to invite Bob, and because this is already busy, only this phone rings, and you can answer or decline. If you answer, now they are two separate two-party calls. It also shows how to do sequential invites. Let's go to the multi-party video conferencing. So the call signaling part that I described earlier is for one party invites, the other party answers. In most of the video conferencing systems that we see today, it's more like you are given some kind of conference URL or name or ID, and you join that. So this one shows how to do that. As an example, the conference is sync up. These two people joined. This one says also join, and this one creates says sync up 2, and he joins there. Now this guy wants to leave this and join sync up 2, joins there. Simple join leave use case. This can be combined with the call signaling to create an invite answer use case, where what happens in this call signaling is that people register and call, but as process of call, they also send their conference URL so that other people can join that call. I call this invite answer use case. So in this case, let's register all these users. And then when Alice wants to invite, say, Carol answers. Now they are part of this call, right? I leave this. This guy doesn't get disconnected because he's still joined the call. Say I say call 1, 2, 3 and join that. And now I invite somebody called Bob. Bob answers. Bob is part of call 1, 2, 3. I leave this. I try to invite Alice. Alice can answer the call, redirect the call so that Bob will be asked to join Alice's existing call, call 1, 2, 3, instead of Carol's call, which is here, or you can decline it. So if I redirect, Carol also joined Bob's call, Alice's call. There are many use cases which are supported as part of this invite answer. The details are explained here as well as in the implementation. One of the things for video conferencing is multi-party layout. So I have a box layout which is very flexible. I call it Flexbox component. It implements simple layout similar to the Flex CSS style for display of boxes, but it also includes other layout styles like grid, pagination, line display for carousel, as well as inline block kind of stuff, and so on. So here I'm going to show, there are a lot of details which will be good to go through, but for the demo what I'm going to show is just this one. This is the Flexbox in 4 different displays: inline block, grid, flex, and page, and it shows how the boxes appear. They can be potentially video conferencing videos from different participants, as randomly the new videos are added or removed from this call or conference. Some of the videos are in portrait mode, some of the videos are in landscape mode, and the overall window shape also changes periodically randomly. Some attributes define how certain videos appear. In particular, float attribute makes a video bigger than all the others. So similar to things like if you are sharing a screen, you want a screen share video to be bigger, or if you want a speaker video to be bigger in a presenter mode, you can do that kind of stuff by assigning one of the videos as float. This one shows the layout in 5 different display alternatives using the same component, and it shows how the bigger video appears in different ways. Now you can also experiment with this customizable display app, where it shows how different things display when things are in different modes. As an example, if I do it in page mode versus picture in picture mode and so on, if I change the overall size of the box to be different, how they will adjust. If I add new videos, how they will adjust. If I double click on one of the video, what will happen, and so on. Now this Flexbox is pretty versatile and used by a lot of applications code that is part of RTC Bricks for multimedia conferencing, demos, and so on. I'm not going to go into those immediately, but what I wanted to show is the next part of this, which is the multi-party conference. Okay, so here is the components for multi-party multimedia collaborations. They are described here. This one are all the components beyond just multi-party tool, multimedia collaboration tools. How to implement a new one is shown here. Text chat. Text chat is probably the basic collaboration tool. I implement several web components to accomplish this. Text feed displays the chat history. Then there is a text chat which includes this and bunch of other things to implement the whole text chat interface. It uses common instant messenger features like smileys, beeping when the message is received, and so on. This one just allows you to test a simple text feed, and smileys. All the attributes, properties, methods are displayed, included in detail, described in detail. You can also share images by dragging and dropping an image file. Now text feed bubbles extends the text feed by making the text messages appear as speech bubbles, which is very common in many of the existing instant messaging clients or video conferencing clients. This one shows various different configurations for style and attributes that were used for these 10 different instances of text feed bubbles, and how the styles affected their look and feel. So this is pretty fancy here, and simple ones, and this is without text feed bubbles, just the plain ones. Like I said, there are a lot of attributes, style attributes, other attributes which allow you to customize these things. This application allows you to see all those attributes in real time, be able to modify them. As an example, this shows where the speech bubble arrow appears, so you can change it to another mode which appears like this, or I can change it to, say, this mode, which is more compact, more fancier. Whether I want my self messages to be displayed on the left or right, whether we want HTML to be displayed, linkification of detect links in the messages and make it clickable, and so on, whether we want icons to be displayed, and how. So a lot of customization possible in this component. This one just shows the customization and use of rich text editor. So here Hi there. I can make it bold. How are you? That appears as bold. You can insert images, you can change other things and so on. A lot of shade editor features allowed in this. Another feature that I have is something called as editable messages. So you can have message like this, 1, 2, and 3, and I can go to 2 and make it yes 2. So here you can see that 2 was removed and yes 2 was added, and in this case, because some attribute was changed, the actual message got replaced. So this is editable message implemented with some customization where either you can replace the original message or strike it out and display the new message. With text chat bubble, it becomes more fancier. So I can say 1, 2, 3. When I use the up arrow, it goes to the actual message, 1 really, and changes that, allows you to change that. There are a lot of customization again in this, which allows you to do those things differently. To display the power of this flexibility of text chat component model, I also implemented the user interface, which looks similar to the Slack messaging user interface. This one shows that. The messages appear pretty similar to that. Editing is also there. And then you can use all these things to see how they will look like when certain things are different, how they will look like when thread view is displayed or something else is there and so on. So this is a derived component of the text feed, which makes it look like something, some popular enterprise messaging client. Displaying user roster is important because it allows you to see the participants in the video call or even a contact list. I have a simple implementation of this. Allows you to change the stuff and see how they behave. A lot of customization possible in this as well. You can see how they behave, change various attributes, see them in real time here. So finally, the multimedia chat, one of the more complex component which displays the user interface for a video conferencing application. It includes other components like text chat, user roster, flexbox for videos, and a bunch of other things. And again, highly customizable, allows you to add toolbars, menus, and so on. There are 4 different display options that I have implemented currently. There is a messenger, which looks like text chat. There is a hangout, which looks like hangout with text chat on the left or right, depending on your configuration. Then there's a film strip, which displays videos in the film strip, and then there is a video city kind of uh, embedded video box model. This one allows you to try and see the differences between all those. You can customize, obviously. Hi there, messages are all over the place, and here, because the way this behaves, it won't show anything text chat unless you join the call or start the text chat. Boxes, let me enable webcam here, there's a film strip. When this joins, now you have 3-party webcam. This can also enter, and 4-party webcam. This one already has webcam, so let me remove that. Okay. Then there are menu items here to do other things, as well as there's toolbar like these, which can use. Many of these are customizable. You can make your own toolbars and menu items. This one allows you to see how things behave when you change some of the properties and attributes. So for example, if I change to video city, this is how it's going to look like. If I go back to hangout, this is how it's going to look like. and I can show, I can decide where the text chat should be and so on, and the order of text chat and other things basically determines that. So for example, if I make video as 0, click on reorder, or video as 1, click on reorder. Oh, maybe it's not that easy currently. Oh, this is for toolbar menus. What I need is include here. Flexbox, I make it 1, and say reorder. So video appearing before the other one, and so on. So a lot of customization for all the individual components as well as the overall media chat component, which allows you to customize how things will look and feel in your actual video conferencing application. What kind of text input you want to use, whether you want to use a rich text editor, whether you want to use bubbles for text chat feed, and so on. There are other features that I'm not going to demonstrate here because there are a lot of other things that we need to cover in this. Whiteboard application or component is a simple whiteboard which allows you to draw stuff, include text, and upload images. But the interesting thing here is that you can combine this with a data model and a storage to make it a shared whiteboard between two participants in a video conferencing. So here, these two are essentially two different instances. They could potentially be running on separate machines, connected using the storage that I described earlier, and whatever you draw goes there. And similarly, whatever you draw here goes here. If I include a text, that goes there, and I can say that show my mouse pointer to the other person. So this is showing the mouse pointer to the other person. And I can also take a snapshot of the image, what I draw, everything in an image file. Another shared collaboration tool is called Logged Notepad, which is a text editor which allows you to edit, but here it's logged, so only one person can be editing at a time. So for example, this person starts editing, first one, second one, the changes go to all the other participants who are in the call, but unless this person releases the lock, the other person cannot edit it. So if I do this, he gets notified, he releases the lock, this person can now edit. If you don't do any input, the lock automatically expires after some time. So that's another thing that allows it to be more interactive. Shared editor is just like editing together. It doesn't need a lock, but it also provides a lock option in case you want to avoid any accidental conflicts, just in case. But the idea is the same. You know, you have a rich editor. It says what was changed here, and I am happy to see this, and I can change its font. This guy can go here and change italic, and it kind of syncs everything together. Now there are details of how the incremental changes versus the full changes are propagated to participants. Those are mentioned in the description. You can also upload and download from the storage on the server, and this allows you to see how the behavior will look like with various attributes changed. So in addition to these collaboration tools, I also implemented games which can be shared in a video call or conference. So this is a simple chessboard where it allows you to move pieces. It doesn't impose any restrictions, so you can move it anywhere. But the goal is to show how this shared games can be implemented using shared storage so that two people can play together. So here there is a first game between first user, second users, two independent games going on. This one moved, so the other participant has flipped the board and see the flipped board, and then he can move his own stuff and so on. This is a separate game with a separate resource path on the shared storage, so that doesn't interfere with the first game, even though they are in the same video call, as an example. Ludo board, another example of a shared game. allows you to, roll the dice, move the pieces, doesn't impose any restrictions, but allows you to have a shared board view and control across participants. Now this is interesting. So there is a ability to add an application, which can be a third-party application, as part of a video call and share it with others. So there are APIs like start share, stop share, and so on that are described here. What I'm going to show here is a shared app called Survey that I created, which is now sent in a video call. So this is a collaboration call between 4 users, first, second, third, fourth. They are using the media chat in 4 different configurations. And what I do here is go to the menu and say participant survey. This is the owner of the survey. I can say something here like do you like K-pop or Swift, Taylor Swift. And then in the option I can say K-pop or Taylor Swift. Press enter. The survey goes to everyone. When people start responding, the owner receives feedback in real time in this application, because that's how it is implemented. And once the survey closes, either because of timeout or the owner decides to close it or so on, the result can get propagated to everyone. So I closed it, the result got propagated to everyone. So survey is one application which is written using the APIs that are part of media chat, but there can be other applications that can be written. I have also implemented slideshow using the file viewer application that allows you to share files with others. In addition, you can also do webcam share, screen share, and so on. In addition to the default webcam that is you're already sharing, you can share chess and this kind of stuff. So let me just go back to the previous demo and see if I have those. So I shared a bunch of photos, and people can just see them independent of each other. Once they are done with the album, they can close that, or they can leave it like that, or I can share it with synchronization. So what I can say is get if they want. So when the owner navigates to the next page, everybody else's view also goes back to the particular image, and other people are basically free to move to next one depending on what display layout they are using. Like this one doesn't allow it, but this one allows it. Okay. Then there is say this guy already shares a webcam, and then I can do another share webcam. So this is another webcam, and I say save. Now hopefully 2 webcams will be shared from here. So when this guy joins, you'll see 2 webcams from the other person. This webcam is not shared as the webcam in the call, but more like a shared content using the APIs of the media chat. There are a bunch of other examples that are here that you can try out. The next topic I want to show is the telephony call signaling components that I have implemented as part of this project. So there is a phone state and there is a conference state. The phone state implements some of the logic that I described earlier in those components. So you don't have to repeat that every time in every application. The idea is similar. You can register with the same name. When you receive a call, you can answer, but those are part of the component now. Those application logic for call signaling are part of the component, and that uses the shared storage that I described earlier. Conference state, similar thing. You can join a conference, leave a conference, the state maintains the membership. But the more important one here is the click to call component. The idea behind this is telephony is not just phone call and conference. There are a lot of other application logic call signaling which have been researched and implemented in a lot of different use cases, such as call queues, call distribution. How do you handle incoming call when you already are in a call? Do you have multiple lines? Do you show missed call? Do you show something else? So all those things are implemented using a very simple abstraction in using click to call, where there is one button, maybe two buttons if you would like, which can allow you to do all this processing. The details I mentioned here, this demo shows many of those use cases where you click on, say for example, if I click on it, what will happen? Click to video call Bob from Alice. So this one is configured where the other party is Bob. So when I click on it, Bob's phone will ring. If I want to answer, I have to click and hold. And now it answered. So Bob's user interface is in a new window, and Alice user interface is locally. So this is again configured by using some attributes in those click to call components. So click to call component is very versatile, very customizable, allows you to basically place a small component on the web page or somewhere and accomplish a wide range of use cases. There are use cases for call queuing, call distribution, and audio video conference join and so on. So this one, let's try this one. It distributes calls to Alice and Bob. So let's say I go to Alice. Now Alice rings first because it's sequential. I click on it, I cancel it. So now Alice declined, Bob is ringing. Bob can answer by click and hold, same thing. And it's an audio call, so it didn't launch a new window, but I can hear audio here connected from here to here. Similarly, incoming call queue here, where people who call Carol will receive call here, and it will have three phone listening for call queuing. So when the call comes in, it can basically decide whether it wants to receive or not. So these are the different audio video communication collaboration tools that I wanted to cover as part of this demo. We went through many of these, including text chat, some of the storage components, media chat, flex boxes for displaying how video layout appears and so on, and some of the external tools like whiteboard, chessboard, as well as shared applications which are not shown here in this demo video. Thank you.